My name is Mark Iantorno, and I'm here to talk about something I am very passionate about, and that's custom views in Android and drawing them on the screen. Before I get into that, I just want to say thanks to Eric and his colleagues. I know they all put a lot of work into bringing back the Toronto Android developer group. It helps get new developers in Toronto connect to what's going on. It keeps old guys like me connected as well. So just a big thanks to him, and I really appreciate it. So a little bit about who I am. I've been a developer for almost a decade now, which is kind of scary to think about. I started at small startups that were about 5 to 15 people in size, and I've worked in companies as large as 60,000 people worldwide. So I've kind of seen the whole spectrum of different organizations you can work for. Currently, I work at the Toronto General Hospital at a place called the Center for Global E-Health Innovation. We're a not-for-profit, grant-based organization. We make apps for healthcare. We're part of the University Health Network. It's the largest research organization for healthcare in Canada outside of BC, but I think British Columbia considers all their hospitals to be one big hospital, so they don't really count in that calculation. A little bit about the work I do and why I'm passionate about UI. So we work with clinicians and doctors at the hospital to make apps to help patients who are dealing with chronic conditions. So these are patients that have to deal with their illnesses or side effects from their illnesses or treatments on a day-to-day basis. These are things like heart failure, COPD, which is lung failure, SPOC. Leonard Nimoy died from that just last year. Diabetes, prostate cancer. I had the privilege recently of working with sick kids to help develop apps for juvenile arthritis and chronic pain. Our hope is that by making these apps, we can kind of make life easier for these patients and better connect them to their clinicians and healthcare staff. And it helps identify problems before they become really serious. And it's beneficial for everyone in that way, because we take stress off the emergency rooms and healthcare system in general. And also, we empower patients. Oftentimes, patients will complain that they feel like they are the end product of this giant healthcare machine. And we kind of make them part of the process, part of their recovery or treatment, depending on the disease they have. And I've said it once, I'll say it again, not everybody I work with agrees with me on this. While the apps are nice, they're actually not the most important part of the whole equation. I think the most important part is getting someone to take a reading and see that quantifiable number on a screen on a regular basis and relate that back to their lifestyle, the choices they make, and it just increases awareness overall. So UI UX is important. Nothing that I do or any who I work with really, or anyone in this space is doing is rocket science. It's connecting to a Bluetooth peripheral, taking that data, loading into a backend like an SQL database, syncing that to some kind of server somewhere. This is stuff that's done every day by hundreds of thousands of apps in the Play Store. You do it when you connect to your Bluetooth speakers at the cottage. You do it when you check your bank accounts on your mobile phone app. So nothing is special about that. And we have to focus on the look and feel of the application, because if the patient doesn't like using the app and they don't want to go back and use it every day, it's not going to help them. And it relates back to the team that I work with, and this is going to sound really horrible to the majority of developers that I tell this to, but over half of my team is design and healthcare human factors engineers, so no programmers. We actually exist on a floor of the hospital that has the largest human factors testing lab in North America. So what we do is we run our wireframes and our applications through with patients in these rooms. We observe them through one-way glass, we make notes, and we take that feedback and we put that back into our applications. So it's a really, really unique working environment. I've never worked in anything like this before, and it kind of opens your eyes to a lot of things that you don't normally consider. So the two biggest takeaways I've had from working on this job for the last 3 years is number one, if you go to developer.android.com, you look at the view class. That's the class that most of the UI components are based on. It has about 130 direct subclasses to it. The second thing I've learned is that there could be 13,000 direct subclasses, and designers would still say that none of them did what they wanted them to do and would ask me to make custom components for them. And you may ask, like, with no shortage of options and all these views to choose from, why use them. And when you use them sparingly, they kind of provide this sense of whimsy or surprise to the user. It makes them want to come back and use your app. But that being said, if you use them too much, your app will kind of look like a PowerPoint presentation from 1995. So you have to find a balance. So just a couple examples from the App Store that I really like and I use on an everyday basis. First one's the Google Fit app. Something like this. I use it for tracking my cycling and my running. Really neat little animation. You're not going to find that in the standard view library. But every day, like you go in, you set a goal for yourself and it tells you, oh hey, you met your goal. It's nothing special. It doesn't really add to the data of the app. It's about the user experience. Second one, Second Cup Coffee app. As a disclaimer, I hate Second Cup Coffee. I think it's gross. I'm not here to talk for the company, but it's a really neat application. The developer made this is in the room right now. I won't point them out, but if you want to talk to them later, you can come talk to me and I'll show you. It's really neat. So you have this app on your phone, you just shake it around as you get these little coffee points, and it's got physics. And like I said, I don't even drink the coffee. I keep this on my phone just to play with this because I think it's so cool. So it's good to keep this in mind because often we get into this mindset where designers will come to us and be like, hey, I want you to make this, and your response would be like, well, this isn't what an Android app looks like. Oh, sorry, this isn't what an Android app looks like. And that may be true for the most part. It may not be what a typical Android app looks like, but it could be what your Android apps look like. And like I said, I'm guilty of it, so don't feel bad if you said this as well. That being said, don't throw out best practices for the platform. Don't start putting like tab buttons on the bottom of your screen or doing crazy iOS things. So there's a balance that you need to kind of reach. Today I'm kind of going to go over a couple of examples from the work that I've done in the hospital. I'll talk about why we chose to do them as custom UI components, go over a little bit of how we program them, and show you some code on the screen. I'm going to try to go into detail, but not too much. My main goal here is to give you the language so that if you want to do this in your own time, after you can go to Stack Overflow or go to Google, look this up. There's lots of resources out there. So first things first, we're going to talk about drawing bitmaps. Most of us usually depend on image views or setting it to the background of a view to do this. But that's not always the best case when we're talking about doing custom UI components. And this is where it gets a bit tricky, just to cover a few basics before I show you the exact example. Most of custom drawing relies on extending a class that already exists. So for our first example, we're going to take our floating action button and make it do a little bit more than a regular floating action button. But it doesn't have to be a floating action button. It could be a frame layout, be an image view, be a relative layout. Whatever view exists already that you want to do more with, you can just extend it like this. And the neat thing is you keep all that original functionality. And the great thing about it is you can treat it in your XML like any other view that you would normally paint. So you just put it in there, and Android is totally agnostic to what kind of view it is. It just paints it like it would any other Android view or layout. So it's really neat. The next thing you have to realize is that everything in the Android universe, big asterisk there, minus like one or two views that aren't really important to this talk right now, relies on the onDraw method. So everything that gets painted to the screen relies on onDraw. So if we want to do any kind of custom drawing, we have to override this method. When it comes to the Toronto Android developer groups, I know there's a mix between junior and senior devs. If you're confused at any of the terminology, like extending a class or overriding a class, come talk to me afterwards. I'll give you like a little explanation of what that means in Java 101 primer. If you're not comfortable with it, like please don't hesitate to ask later on. But you'll see here that we have our onDraw method. We'll override it, and it gets this canvas object in. So what the canvas object is you can think of it like a Bob Ross style painting surface that you are painting these objects to. It isn't actually, it's more of an API that lets us pass these draw calls down to the surface that's being drawn on. But when you're starting, you can just think of it like you're painting on a canvas. It makes it really straightforward. So when you're painting, you kind of need to know where things are on the screen. And we take for granted that Android can be a really, really busy place. So if you look, this is the landing page on the Android Twitter app for the eHealth Devs profile that I tweet to. If you look at the top there, just that first 28 pixels, the status bar, there's 14 icons in there, and a date, and then we're not even counting all the rest of the views there. So we have text views, we have image views, we have linear layouts, we have relative layouts. We need a way to kind of organize this. And it's kind of counterintuitive. If anyone here has done like algebra or math, we're used to a graph starting at the bottom and then going up like this. So higher is better until you get to the top right. But in Android, when you're talking about your screen, the coordinate system starts on the top left at 0, 0, and then progresses all the way to the bottom right of the screen to the width and height in pixels. And the same holds true, it's iterative. So if you go into, you put another view in the middle of your screen. So in this case, I have a frame layout and I've set Grumpy Cat to the background. If I place any view inside that, it now conforms to the coordinate system of that view. That starts at 0, 0 on the top left and goes to the width and height, maximum size of the view. So if you're ever interested in seeing how your application is laying out your views or the padding or ever having issues, you can go to your settings, developers option menu, and click show layout bounds. If you can't get this to work, come see me after again. I'll show you how to put your phone in developer mode. And if you look at the view we had before, this is what it looks like. And what you see is you see the corners of all your views. You see the pink areas there are padding. And it helps you debug, especially when you're developing. And I really encourage you, if you're starting out, download some apps from the Play Store, put show layout bounds on, take a look at how other developers are doing it, and it gives you insight, because a lot of times we overuse layouts when we're first starting in Android. This is a really nice tool to kind of show you what's going on. So our first example is this screen. So like I said, we make apps to help people deal with chronic conditions. This is our app called Medley. So this is an elderly gentleman who wants to monitor their weight, their blood pressure, heart rate, blood sugar, and also put in some symptoms. Since we're working with an elderly population, we have to consider the fact that their vision might not be 100%. We want a highlight option for the screen they can click on. So we have a design team that decided we want a little special snowflake floating action button that's not like traditional action buttons. So our floating action button traditionally would just be a solid colored circle with a plus in the middle. In this case, we had user testing. Users are more drawn to the button when it has an outline. So the designers kind of put together this little weird shaped outline on the outside. So you give this to a junior developer, they put on their junior developer cap. First thing they do, they say, I got this, Mark. I'm going to take an image view, I'm going to put background in the image view to be this circle, I'm going to put it in front of the floating action button in my layout, and then I'm going to ignore clicks on the image view and bam, works perfectly. And it does. Like, I won't take that away from the junior developers. It does work perfectly, but we can do it better. And I'm a senior developer now, so I have to kind of justify the small increase in pay. So there was a guy called Roman Gee who did a lot of the UI work for Android, and he still blogs now. He does most of the photography now. So if you have a Chromecast, a lot of the photography on your Chromecast that flashed on the screen is him. But he was really fundamentally involved in the start of Android UI components. And his quote is, every view, or worse, every layout manager you add to your application, it comes at a cost. Initialization, layout, and drawing all become slower. It doesn't matter in the floating action button example. It's only one view. But I'm a firm believer that if you enforce these kind of practices even on the simplest views, then when you get to more complicated views like grid layouts or list views or view pages where you're doing tens or hundreds or if not more draw calls over and over again, it's going to become second nature and you're going to do it right away from the get-go there too. So how do we do this? Well, we have to think like the OS. The OS is going to take this bitmap, it's going to load it in from memory, step number one. It's going to scale it to the size we want, and then it's going to draw it to the canvas. So it's three basic steps, and then we have to paint it, right? So first step, really simple, and the nice thing about these bitmap methods is the syntax is so straightforward and easy to read. So all we do is we create our bitmap object there, mcircle, and we just call the static method bitmap factory, decode resource, you pass in your resources, and then our ID is just our drawable, my fancy bitmap, and it loads it in and creates the circle for us. It's super easy. So you're going to do this the first time you're going to put it in your onDraw method. And the only thing you should really be doing in your onDraw method, surprisingly enough, is drawing. The worst case scenario, or sorry, I should say the best case scenario, is you're going to cram all your loading in your onDraw method the first time you do this, and it's going to run really horribly because you're loading it in every time you call onDraw. The UI is going to not be responsive. It's going to jitter. It's going to be a really poor user experience. The best case scenario, or sorry, I should say, I messed that up. The worst case scenario would be that you put it in your OnDraw and you test it on your Monster Nexus 6 phone. It's going to run amazing. Then you're going to put it in your clinical trial, in my case, you're going to put it on the Play Store, and you're going to get people using real-world Android phones that are like old school Moto Gs, or old school Samsung Galaxy Cores, or other off-brand Moto phones. And you're going to get feedback in the Play Store being like, this app sucks, it's slow, it's not responsive. And then you have to go back after the fact and figure out why it is performing that way. So first thing you want to do is separate your drawing from your initialization. And we do that by putting in our constructor an initialization method. And it's just called once. It's called once when the view is created, you load your bitmap in, and you never do it again. It's good memory management, it's good practice, and this is just the best way. So we've loaded it in now. We need to scale it to the right size of the screen, right? Because bitmaps in Android, you're only going to do what we tell it to do. So if you load in a bitmap that's this big, and you paint it to a view that's this big, you're only going to get the top part of your circle in the view. And the reverse is totally true as well. If you load in a bitmap that's this big, and you paint it to a view that's this big, you're only going to get a little bitmap in the top left corner when you draw. So you have to detect how big your view is and scale the image to that size. And you're going to remember this talk when you're doing it, and you're going to say, well, that Mark guy told me to put everything in this initialization method, and you're going to call, okay, I'm going to get this variable, it's called width, a variable, it's called height, I'm going to call get measured width and get measured height, and you're going to get 0 because the view doesn't exist yet. Every day you can log on Stack Overflow on Android questions, and every day someone's asking, why is get width and get height returning 0? I can't figure it out, and it's because the view doesn't exist yet. There are 4 steps in Android that happen in drawing. First thing is on create view is called. Second thing, on measure view is called. Third thing, on layout is called. And then fourth, on draw is called. If you call on measured width or height before on measured is called, you get 0. If you call get width or get height before layout is called, you get 0. So the solution to this is you override your on measure method, and you put get measured height and get measured width in there. And then you get the width and height of the view that you're looking for. Then what you do again, the syntax is so straightforward, you just call the static method create scale bitmap in the bitmap library. Pass in your original circle, the new width, the new height, and then the last argument you can just leave as false, but it has to do with interpolation and scaling. If you want to know more about that, come talk to me after. I can bore you about it for a long time. So you have your created bitmap, you scaled it, and now you need to draw it to the canvas. Real simple, and now you use your onDraw method. You go canvas.drawBitmap, pass in your scaled bitmap. The x coordinate is 0, the y coordinate is 0, and the last argument is a paint object, which you don't need, so you can just pass it into them. Perfect. And it sounds complicated, but it's actually only 3 lines of code, and it's extraordinarily powerful. So all you're doing is loading it in with decode resource, you're scaling it with create scaled bitmap, and then you're drawing it. This is the foundation for sprite animation. This is the foundation for a lot of basic, really cool transitions. I remember when the first transition animations came out, when you were looking at the photo album in Android, and you would click on the button and go, and it would be at the top of the screen. This is before we had the support libraries. This is how we did it. You would scale the image in, and then draw it and scale it up until it's the size of the new view. So this was before the support libraries. It's really, really powerful stuff. And then you get your finished floating action button there. And it performs just like a regular action button. So, second example, we see an example of drawing a bitmap. There are going to be times when you need to draw lines, you need to draw shapes. And you may be asking, like, when do I use XML to draw these things? When do I not use XML to draw these things? XML is a really, really, really powerful drawing resource in Android. You can draw a lot of great things, but it can't draw triangles. So this is what we want to draw. Well, it can draw triangles, it just doesn't draw them well. I'm sure someone here will be like, I've drawn a triangle before, but it doesn't draw them very well. So we want to draw this triangle here. This is from our I Can Cope with Pain app for kids. XML drawables, like I said, you can draw a lot of things. All these views are from the Medley app, and they're all drawn with XML. No bitmaps involved in any of those. So if you want to look at just the top view here, which is from the My Symptoms survey, you can create that circle there just by creating an XML file like this using the shape tag. You label it as an oval shape, and then you just control the stroke width, which is 4 dp, and the color, which is some hex value that amounts to that blue. And then really nice thing is you can take this file, put it in your drawables folder, and treat it like you would any other drawable. And the same thing holds true for the background. The background of that view is just a rectangle. So it's the shape tag there, and we set the shape to rectangle. You set the roundness of all 4 of the corners. In this case, they're all the same. It's all 8 dp radius, and the color is white. So this is the best kind of developer art because oftentimes we'll ask designers, like, give me the resources, give me the resources. But we're looking at 5 different bitmaps or drawables or PNGs for each one of those images versus a dozen lines of XML code, right? Because you need an image for HDPI, MDPI, XDPI, XXDPI, XXXDPI. It's a waste of space. It's more efficient to do it this way. With that being said, we can't draw triangles. And you may be saying, why not draw with a bitmap? Because it looks like shit. And you will notice this now when you download apps from the App Store. You will see, especially on higher end phones, the scaling's not perfect. Android tries to be smart. It will scale in these wonderful shapes for you. And you'll be annoyed because your view is 20 pixels wide and the top of the triangle needs to be at 10 and a half pixels in the middle. But it can't do that because it's drawing a half number and the scaling's weird. So you get these weird kind of fading artifacts on the outside. So again, we can do it better, and I generally enforce that no bitmaps allowed for those kinds of simple shapes. So we kind of need to turn Android into an Etch-a-Sketch. And the way we do this is we use the path object, and the path object is really, really great for drawing basic geometric lines, curves, those kinds of basic shapes. It's quick and very powerful. So if you want to think about the path object as the direction and size that you're drawing, the paint object is its complement. It's the color and style that you're drawing as well. It's used all over custom drawing to the canvas. It's not unique to the to the path. So if you're drawing a bitmap, you can pass in the paint object to do modifications to that bitmap. If you're doing typeface modifications to things like font, paint plays a role there as well. So just, again, the syntax is super simple. If you want to create a paint object, all you do is just say new paint object. You set the color to black. Stroke width, in our case, will be 3 pixels. And then you have 2 options here as a beginner. Stroke is your style, or stroke and fill, which do exactly what you think they would do. One draws the outline of shape, one draws the outline and fills it in. So if you want to draw just a regular black box on the screen, we initialize our paint object like we did on the last slide, and then we create a path object. And with that path object, we give it coordinates. We say we start at 0, 0, we're going to move across to 10, 0, we're going to move down to 10, 10, back to 0, 10, and then we're going to close the path. And then we just pass into the canvas that path with the paint object on a draw path call, and we get a wonderful little circle on this extremely low density phone that is 10 pixels wide and 10 pixels high. It starts at 0, 0. So it's really, really straightforward and really, really powerful what you can do with it. So how do we draw our little triangle? Same approach. We go and create this method that we're going to call in our onDraw, and we pass in our canvas to our draw triangle method. We create a new paint, except this time we're going to do fill and stroke as our style. If we want a filled in triangle, we're going to set the color to blue. We're going to set our stroke width to 1. Because we're filling it in, it doesn't really matter. And then we're going to start at the bottom. Bottom, for you guys, yeah. Bottom with x equals 0 is our coordinate, and y equals the view height, which is the bottom. Then with our path, all we're going to do is draw triangles. So we go across the bottom, back up halfway to the top, and then back down. And then you're going to notice the only difference here is we have the fill type. This is an algorithm that Android uses to fill in a shape. There are other options. When you're starting, I just suggest to use even on. This is because sometimes if you think about a child sketching on a piece of paper, they may go all over the place. How's Android going to know what to fill in? So there's algorithms that determine this. In this case, the simplest one, it'll fill in the inside of our triangle. And then all we do is close the path and call canvas.drawPath again, pass in our path and our page. And we got our wonderful little wheel. So the kids actually really like this, and so they can rate their pain every day on a scale from 1 to 10. And it has Mr. Jellybean Man, who is in moderate pain today. Okay, so these are two basic, fundamental drawing tools here. It does get more complicated. These are the foundations of most of the animations you're going to do. I don't want to intimidate you by saying the rabbit hole is deep, because if you know this, you can go online and learn. And there's so much out there in terms of resources that I really encourage you to do it. That being said, I don't want you to feel like you have to do everything your design team is telling you to. It's okay to push back. The best teams that I've worked on are where design and development are very aware of each other's limitations, and they only push them a little bit. And it's kind of our responsibility as developers to facilitate that education, because we're the ones with our butts in the seats and our hands on the keyboards. So talk with your design team. Tell them what's possible, tell them what you want to try, and let them know, like, there's a cost to everything, right, as you're developing, and sometimes they're unaware of it. And I don't know if you're saying this now, but I still argue with the design guys at my work on a daily basis, minimum. So take what I've said today. I want you to go out there, create something cool. I'd really like to see it. If you do, send it to me. If you have any questions too, you can email me there. I'd be more than happy to answer them. I've already gotten back to a bunch of guys in the group from last time. It would also make my day if you followed me on Twitter. I know that's cheesy, but I tweet for the whole center there at the hospital about healthcare, about programming. So yeah, I really appreciate it. Thank you very much again. Thanks again to Eric and his team. If you have any questions, I know some people wanted to say about ways they did things last time, so if you want to tell me about that too, I'd be more happy to hear that. Thanks very much. Yes.
How do you guys handle working with really large bitmaps, and like for low-end devices, they might like run out of memory? So for example, if you need to like blur out the entire screen of like a bitmap, is there a recommended way that you guys do it?
So it's a really good question, and so it should be able to handle a bitmap as large as a screen. The device should be able to do that, right? But it can't. There are larger issues at play with that device, right? So it's about how you load that bitmap. I'm gonna put that away. It's about how you load that bitmap and how you manage creating that bitmap. So in reality, whenever you're doing any UI heavy operations, you should not be doing it on the UI thread. So you're relying on things like async tasks. You can do it in own separate drawables, and then you can use handler objects to post it back to the UI thread. But I find the biggest thing that a lot of people do, and that's why I tried to emphasize that in the on-draw method, take everything off the UI thread. Because worst case scenario, if you're handling that well and it crashes or something goes horribly wrong, at least it won't mess up the user's experience. Like worst case scenario, they won't get an avatar to load, so they won't get the picture of their cat on the screen, something like that. But at least the app will continue to work and you're handling the problem. I think that's, and again, it's case by case, right? So I don't know exactly what you're doing.
Do you do the offloading in the view class, like in your extended view class itself, or do you do it like in activity? Or
so it depends, right? I would say that if you're, it depends on where that image is coming from and what you're doing with it. To give you an example, today I was doing a lot of really intensive operations that were all happening in the adapter, as horrible as that would be to set, right? So it depends on, are you making network calls? Are you calling to a database? Is it loaded locally? Where is the data coming from? Like that's how I made my decision on where I'm going to do that. Any other questions?
yeah, sure.
Question. Do you integrate resources for every resolution, or do you?
I can say that one more time.
Could you create resources for every resolution, like extra large, extra large, etc.? Or
Yes. So for when we're doing, we do clinical trials, and now we're getting the clinical trials. We're shipping to patient phones. So it's BYO to bring their own device, right? So we need to be prepared for someone bringing the like crappiest phone, like Android phone possible. Like we'll cut off the API off at like 18, version 18, right? It has to be above that. But we're talking. I will test on. Do you know what a Model E is? So on my desk, I have an original Model E, and I have like a Nexus 6, and and it has to run on the Moto E, and it has to run on the Nexus 6. And sometimes we'll load it on a tablet just for kicks to see what it looks like. With mixed results, but yeah, you have to be able to kind of cater to your audience in our case. We expect them to Any other questions? Yep, go for it.
How do you decide how complicated your views are? So for example, like we're giving an example of the spinning wheel. There's tons of different views going on, right? So do you create a custom view for every little thing and then you put them together, or do you actually say like try to group a couple things together and make that into like a bigger view or something?
So let's be clear about the spinning view, that if I could build a time machine to go back in time and tell the design team to go away, I would do that, because it was horrible to me. But it works now, and there's a bunch of different pieces going on. So this is why I said education is an absolutely huge part. You can't have your design team living on a different floor in the building in some cave somewhere, and then they huck a design guide out of it every 6 months and tell you to build it, because the worst thing that can happen is getting a bunch of Apple users or iOS users churning out Android designs all day, and none of them use Android phones, and you're left with this wonky UI that doesn't work. So you have to talk to your design team, and it's about communication, it's about iterative design, and having that good relationship with them. You have to be able to say no when I'm saying no. You have to know when it's okay to say no. So again, I can't really give you a super good answer.
That's just for example here, right? So you have, say, the moderate paint, that's like just a little bit of text, and then you have the wheel and then the numbers and all that stuff. Do you decide that, I want to create the text part, like just a separate, like a small view, and then you bunch these views together, or do you decide, I'm going to make the wheels like into a huge view and then like just do a bigger one?
I'll give you the Coles notes, and if you want to look later, we can go over it because I don't want to bore everybody. This is all one big view. The view basically goes from there to below here, and there is a text drawable, which is a class that I kind of custom text drawable I made. You'll notice that the text kind of starts here, it scales up to here and scales down, and then above that is this constantly sized number. So that's a custom class that I created. It's initialized when the wheel is initialized. So all that gets passed into this wheel is the indexes from whatever minimum number, it's a maximum number, and associated values. And then this guy on top is just an image drawable that we tack. And so then in the on-draw method, we're doing a bunch of quick calculations that are all like trigonometry, like it's turning out cosine and sine and arctans, and then it kind of shapes it and moves them where you need to do it. Yeah, I'd be more than happy to give you the nitty-gritty after. Go for it.
How do you communicate with the designer about animation?
Good animation. Okay, so that's a really, really good question. And so I am not a fan of pair programming, but I am a big, huge proponent of pairing design and development at a keyboard, building like quick prototyping demos, because you know what you can do as a developer. And I'll actually pull this up now. There's this guy called like Wasabi or something like that, who's compiled this gigantic resource of open source Android, here it is, UI widgets that you can look at, and they're awesome. So if you want to sit down with a designer, every time I talk to them, I say, you need to go look at this and look at everything that's out there. It's open source that we can do. And there's tons on here. It's not just like material design stuff. There's loading menus. I can post this to the group after if you want, but like custom calendars, custom buttons that morph. It goes on for days. There's a lot here. I just used this one today in an app I was making. So you sit down with them and you show them what's possible, and then you should tell them what you're comfortable doing. And I really encourage you to sit down, because they kind of have this weird inverse relationship. I find designers will be like, okay, I need you to change the size of like this font. I'll come back in like 3 hours. I don't want to stress you out. And then on the flip side, they'll come back the next day and be like, okay, so I need this like view to fly in like this and spin around and then like explode into a million stars. So that's like 15 minutes, right? Because they don't have any idea of cost versus return, like what they're getting. And so sitting them down, showing them this, showing them the code that's like involved, like if not how it works, but like the amounts and what you're comfortable doing is a huge step. And it's a conversation you have to have. And you get what you put in that case. So yeah, that's the best way to answer it. I sit down a lot with designers. They're not my designers, they're designers. But yeah. Any other questions? Great. Thank you very much, guys. Really appreciate it.